Scanner School session number 43, an introduction to NXDN.
Welcome to the Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
So welcome to Scanner School. My name is Phil Lichtenberger. This is a podcast that teaches you everything you need to know about the scanner radio hobby. Now, to make good on that tagline, we're here to teach you today about NXDN. This is going to be a two-part series. There's an introduction, which will go through the Common Air interface, and conventional NXDN. Next week, we'll talk about NXDN trunking and the two different protocols that are involved over there. This week's session was going a little long with the trunking, so I've decided to split that up and make next week's trunking its own dedicated session. Much like I did with the P25, where I broke that down into an introduction and some trunking as well on that one. So before we get into NXDN, what it is, how it works, and everything else, let's take one brief second and talk about our sponsors. East Coast Pagers is the sponsor of Scanner School. Without East Coast Pagers, there would be no Scanner School, and full transparency, East Coast Pagers is my online.com business where we sell Unication, Apollo, and Swiss phone pagers. Now, East Coast Pagers serves the United States market, and we, again, have one-way, alphanumeric, and those two-tone voice pagers that also support P25. So I want to tell you really quick about the current promotions from Unication. Right now, there's a $50 off a G1 pager. We also have free extended warranties if you buy 20 or more pagers or 20 or more G1 units. And if you're in the market for a really cool P25 pager, the Unication G5 is now $100 off. So that means you're basically buying the G5 for the price of the G4. Now, these promos expire December 21st, 2018. So make sure you contact East Coast Pagers right away for your best price. Now, again, East Coast Pagers sells all of their G-Series pagers with free shipping, basic programming, and a spare belt clip. The G1s also ship with a spare set of Tenergy batteries. So contact eastcoastpagers.com, eastcoastpagers.com for your individual or department quote, custom quote, and we also do POs and tax exemption and whatnot for government agencies. Again, eastcoastpagers.com. So NXDN. NXDN stands for Next Generation Digital Narrowband. Now, NXDN was created in 2003 as a joint venture with Kenwood and Icom. It was developed really to satisfy the FCC's mandate for narrowbanding on VHF and UHF. Right, we had to go from 25 kilohertz wide frequencies down to 12.5 kilohertz, and now eventually too we're dealing with a lot of ultra narrowband, which is at 6.25 kilohertz bandwidth on these frequencies. And we'll talk more about the ultra narrowbanding later on in this segment. But so it was first created in 2003. The protocol was really announced a couple years later at IWCE in 2005, with the very first commercial radios appearing on the market in 2006. Jumping ahead a few years here, though, it was really accepted as a part of the International Telecommunications Union radio communications sector. How's that for a mouthful? Which really is the ITU-R. And this was accepted in 2016 and publishes it officially in 2017 as an International Digital Land Mobile Radio System. This publication in 2017 basically solidified the fact that NXDN was an internationally accepted form of digital communication. Now, let's remember this now. NXDN started in 2003, officially recognized by the ITU-R 2017. That's a pretty large span from the time of being thought of to being, it's an adult almost at that point. So, like I said, NXDN was basically created from Kenwood and Icom. And the whole point, really, besides narrowbanding, was it was supposed to be a commercial use type of digital system, right? We had at the time, you have APCO 25, P25. I think Moto Turbo was kind of starting to get into the mix at that same time here. But reality was, this was created to replace the aging LTR networks that are out there. And, eventually public safety agencies started getting on board as well with NXDN. So again, originally created for the business user, like taxi companies, security, sometimes, those systems that, or those trunk systems that are there for people to rent or at least talk groups on, for those radio groups that kind of go out there and they say, if you don't need your own repeater system, but you still need a two-way device, you can lease the talk groups from us. Those kinds of businesses already had usually LTR systems that were out there, and to graduate into either Turbo or NXDN was the next step in their evolution. So that's really where NXDN was kind of catering into. So again, besides oil deliveries, transportation, bus companies, those kinds of things, there are, again, like I said, some public safety use in NXDN. And even somewhere I read too that the U.S. military, is also a user of the NXDN. Now, I don't exactly know who, what, when, where, or how that's happening, but I do remember seeing that in when I was doing my research for this podcast on NXDN. So really, again, NXDN can be both used as 12.5 kilohertz spacing channel widths, or the ultra narrowband at 6.25 kilohertz spacing. So really what happens is you can fit two 6.25 kilohertz wide channels into a single 12.5 kilohertz wide frequency. Doing this really is said to effectively double the capacity on the system. And we'll talk more about this doubling capacity in a second. But let's take a look here, right? You're mandated to go 12.5 kilohertz wide. So you can either use all of that frequency bandwidth, or you can use half that frequency bandwidth. So when you use half that bandwidth, what happens? You have two options here. Either you have 6.25 and you run right down the middle of that tunnel, and you have this clear space on either side of you where you don't have any interference, right? You have this built-in guard band where you get to keep the channel nice and clean. Or you divide that 12.5 kilohertz in half, and now you got 6.25, and you can now run two lanes of traffic down that single bandwidth or that single tunnel. So this is what I'm saying. Let's keep this in mind here when we talk about NXDN, 6.25 or 12.5. These numbers are going to come into play, and they're going to come in starting now, really. So in the U.S., the FCC has 7 emissions designators for NXDN licenses, 3 of them being for 12.5 kilohertz, 3 of them being for 6.25 kilohertz. One of them is 6.25 for a single analog CWID or a Morse code identification. So of the 12.5 and the 6.25, the 3 are single channel voice, single channel data, and single channel voice and data. So one each, one for 12.5 and one for 6.25. Plus the CWID gives you your 7 emissions designators for licensing for NXDN frequencies. So NXDN is approved for use on VHF and UHF operations. That includes the public safety and the business band spectrum of both VHF and UHF. Not UHF as far as 700 to 800 megahertz, but up and through 512 megahertz. Now, NXDN was created, now again, to be a de facto two-way digital standard. And in order to do so, there was the creation of the NXDN Forum. And the NXDN Forum was really created to be, the speaking or the governing voice of NXDN. The NXDN Forum has 30 members to date, and it includes like radio manufacturers such as JVC Kenwood, Icom, radio test sets from Aeroflex and Anritsu, General Dynamics, dispatch consoles by Zetron, test equipment by Boeing Company, as well as other companies that support IC chips and recording applications and other third-party devices. So there's some really heavy name branding associated with NXDN. When we think like Motorola, we think Moto Turbo. It's kind of that's kind of how that's thought of. But NXDN was, like I said, there's the NXDN Forum. It's a bunch of companies that came together, and they are all involved with the creation of NXDN and how it operates and everything else. NXDN uses an open standard common air interface, or CAI. So the common air interface is very important because the CAI kind of gives the list of standards that NXDN must operate under in order to be considered NXDN. And you really can't sway too much on a lot of the common air interface pieces. There's certain areas of NXDN that manufacturers do have flexibility on, and we'll touch on those in a little bit. But for the most part, things are written to a standard so that you can have multiple pieces of the pie and build out a system. Like, again, you can have a repeater by Kenwood, you can have radios by ICOM, you can have a dispatch console by Zetron, you can have test equipment by Anritsu. So again, you don't have to buy flat Kenwood, flat ICOM, flat anything else in order to maintain a NXDN network under the CAI standard. We have to remember that in advance too, because there are pieces of the puzzle that can lock you into name-specific type of things. So we have talked in the past, when we went into P25, about TDMA, or Time Division Multiple Access. Basically, TDMA is used on DMR, or Motor Turbo, and also on P25. And really what that means is that you take a certain frequency and you split it up into time slots. So what happens really fast is a time slot will turn off and on, off and on. Another one will turn on, off, on, off. Basically what that means is you're alternating. User A, user B, user A, user B, user A, user B on the same frequency. That is TDMA. You're dividing the signal by time. Now on P25, on P25 and on Motor Turbo, you're dividing that into two. You're dividing it into half. That's how you're doubling your capacity on P25 Phase 2 and also on Motor Turbo. Well, NXDN uses a different protocol here. They use FDMA, or Frequency Division Multiple Access. Now, FDMA basically means that the transmissions are separated by the frequency they use. Multiple frequencies can be used at the same time to hold many conversations. Now, if you're scratching your head and you're thinking that sounds a lot like analog, you're exactly right. I guess we want to put it that way. Analog could be a very basic FDMA structure. The one user is tying up that frequency resource for the entire time that they're using it. When you change channels, or you're on a trunk system, say like Motor Turbo, think of a EDAX. We talked about this in the past. EDAX, Motorola Type 1, Type 2, right? Again, those are all FDMA. The voice channels are your frequency division time slots, or voice channels. When you're done using your trunking talk group, you go back to control channel. Boom. Now you use another frequency resource. So here we go again. NXDN, using the mindset of analog, using FDMA, you could, like I said before, we have a 12.5 kilohertz wide signal. You divide that in half. Now you have 6.25 kilohertz. You now divided that frequency in half, and you can now stack on somebody on the first half, on the first 6.25, and somebody on the second half with the second 6.25 to make up that 5.5 kilohertz wide beam width, or bandwidth of the frequency. Two frequencies stacked into one, divided in half, can kind of be your FDMA. I know it's a little bit confusing to think about, but I'm trying to think of a really easy and simple way for you to understand FDMA. So our FDMA splits the channel based on time, right? 01010101 would be an example of me talking to you right now on TDMA, here's me talking to you now on FDMA. I've stopped. I'm starting again. Here's me talking to you on FDMA, right? We're splitting my time in half, but we're dedicating the entire voice path to one FDMA channel. So the other key we have to watch out too, where things are a little bit different between TDMA and FDMA, is timing, right? In order for radios to sync up and to know when the time slot is and to know, when to start decoding and the decode rate and all that, we need to have a timing key involved with TDMA. And that happens every X number of milliseconds. Again, I don't have the spec in front of me, but it takes a certain buffer for TDMA signals to come in for your receiver or your scanner or whatever else you're looking at or listening to align itself with the TDMA time slot so that it knows to start decoding. With FDMA, that could happen a little bit quicker because it's frequency division. So it happens a little bit faster on the FDMA spec. So we talked about how, we have these companies that have already established LTR systems that have users on them. And their growth point or their evolution would be going into NXDN. Well, NXDN, again, thinking about how people would graduate into that protocol, realized that they needed to have a gateway to have users get into it, right? So NXDN, the radios will support analog. They'll support NXDN digital. I also believe too that there's some sort of modules that you can place in there that will convert digital analog to digital, so that the end user can also hear what's going on in there as they're building out their radio system. So with analog being the backbone of NXDN as you're building up your stack, it's great because you can use a lot of the old test equipment you still had. It makes it very familiar to start adding and upgrading systems. And as you start building in, it's really you just start adding the digital hardware. And this will start to allow you to grow into NXDN from an existing analog structure that you already had in place. So it also reduces the complexity of the end user or the system admin, as well as the cost of launching a brand new system. Now, again, to remember, you can keep your old analog users going when you start building out NXDN. Now, NXDN supports its own type of 15-bit voice scrambler. It's unique to NXDN. There's 32,000 codes that are available for voice scrambling. On top of those 15-bit voice scramblers that are built in, NXDN also supports DES and AES encryption. So yes, the big ugly E, the big ugly elephant, can still exist on an NXDN network. NXDN uses RAN codes. So instead of having PL codes, DPL codes on an analog system, now again, we talked about those things, those PL codes and DPL codes. If you want a refresher, I would suggest going back and listening to session 3 of the podcast, scannerschool.com/session3. Again, P25, we talked about NAC codes, and that was again on session 14 at scannerschool.com/session14. But NXDN uses RAN codes, or radio access numbers. Now, there's 63 RAN codes that are available, and a RAN does not need to be defined in order to get on the system. Now, again, no RAN would be CSQ. There's no RAN required. You also have unit IDs, group IDs that can be implemented as well on a single conventional type of NXDN system. Now, again, right now, up until this very point, we've talked strictly about the structure of NXDN, what NXDN is, a little bit about how it came to be. We haven't really broken apart yet the difference between conventional and trunking. Okay, so let's now talk about specific to conventional. NXDN can be used as a point-to-point, radio to radio, dispatch to mobile, dispatch to field unit. No repeater involved, right? Strictly simplex point-to-point. You can operate repeated with a receiver voting where you have multiple repeaters out there and the end user is automatically selected to the best site that can hear them the best. And then that is sent out to the rest of the repeaters in the network. repeated again with IP networking, and also repeated IP networks with site roaming, which means that you have your own home site, and if you travel outside your home area, a repeater can then feed you back into your home system. Basically, you're roaming the same way older cell phones used to work. We would roam onto another carrier, but you still can have cell coverage and make phone calls just like you were on your home network. So now the backhaul, the IP backhaul, the way the repeaters are linked together, those can be defined by the manufacturer of the system. And that does happen. So you may not be able to take a Kenwood repeater and network it with an Icom repeater, right? Because they'll talk a different language over the IP backhaul. So typically when you have a network of repeaters tied together, they'll all be of the same manufacturer. It'll either be all Kenwood or all Icom. Now, again, Kenwood and Icom. Let's think about that for a second here. We have 3 flavors of NXDN. We have the NXDN Standard, which we've been talking about this entire time here. We have Kenwood's flavor of NXDN, which is called NEXEDGE. That's NEXEDGE. And we have Icom's flavor of NXDN, which is called IDAS, or Icom Digital Advanced System. Yeah, yes, IDAS was also the name of Nextel's network at the time. It was lowercase I and DAS. So, yeah, I don't know how that name came about again, but, IDAS has been resurrected from the dead, and Icom is using it for their NXDN system. So here's where we start getting into some of the differences between NXDN NEXEDGE and NXDN IDAS. So the NXDN Standard, again, remember, 6.25 kilohertz wide or 12.5 kilohertz wide. For NEXEDGE, Kenwood's NXDNs, you can have direct, repeated, and voting protocols, and they can either be 6.25 kilohertz or 12.5 kilohertz. With IDAS, direct, repeating, and voting, the only bandwidth available is 6.25 kilohertz. Icom doesn't give you the option of ever going 12.5 kilohertz wide. They want to keep you at ultra narrow at 6.25. And also, just like P25, to kind of put a little ribbon on everything, NXDN uses the exact same vocoder. They use the AMBE+2 vocoder from Digital Voice Systems Incorporated, or DVSI. So again, there's a lot of similarities between P25 and NXDN. So by operating this vocoder in half-rate mode, this is how NXDN can operate within a 6.25 kilohertz wide bandwidth. By operating at full bit rate, it's 12.5. Half rate on this vocoder gives it down to 6.25 kilohertz wide bandwidth. All right, everyone, that is the end of the introduction of NXDN. I know it's a little bit much to digest in one sitting. That's kind of why I broke this in half. I didn't really want to overwhelm anybody, and I when I was recording this and I started getting the trunking, it really started to get very long and drawn out when I brought the trunking into this. So that's why I've decided to break this session into 2 sessions. So look forward next week. We're going to talk more about NXDN trunking. But before we break, I just want to say that all the show notes, everything that we talked about in the session, all of the links and the references that I have used to put this podcast together can be found at scannerschool.com/session43. Also want to thank our Patreon supporters, Mark Beebe, Kenneth Fowler, MT Bono, and James Felling, for their continued support. If you want to know how you can support the Scanner School podcast, just go to scannerschool.com/support. I mean, we got ways out there that you can support us that doesn't cost you anything. If you're an Amazon shopper, scannerschool.com/support. Click on our Amazon banner. Boom, we're making a little bit of money on the side, and you're helping to support the Scanner School podcast. If you shop at Scanner Master, again, we also take PayPal donations and monthly Patreon support as well. So make sure that you subscribe to the Scanner School podcast. This way you know when next week's session comes out and you can continue with this NXDN tutorial. So again, go to scannerschool.subscribe to subscribe to the podcast so you do not miss next week's session. All right, everyone, that's it for this week. We'll continue this next week on Scanner School. We teach you everything you need to know about the scanner radio hobby.
Thanks for listening to the Scanner School podcast. Be sure to visit www.scannerschool.com to access the show notes and bonus content.